Hello. Today in this video, we will be talking about motors and motor control. So the first thing is we need to make sure to do hashtag include, not motor, robot config.h in our main file. You will need to do this for any file you wish to put device controls in. And you always include header files, which means you will get all of this, and all of that stuff is declared in the .cpp file. You just need to include the header file, and you will have all of that stuff working in here. So the first thing is just some basic motor stuff. So the basic command to get a motor to spin is motor.spin. Okay. Which is relatively simple, as you can tell. But there is 3 parameters you want to make sure to give it. 2 of them are optional, but we'll talk about them. So the first one is you need a direction type, which is just forward or reverse. It's always going to be one of those. The second parameter is the velocity. You don't have to do a velocity. You can do motor.setVelocity, which is a function, and you just set it to some number. So that is an option. And the other thing you can do with set velocity is give it a unit like RPM, which is revolutions per minute, or percent. Both work. But what I personally recommend doing is every time you do a motor spin command, just tell it that your second parameter is your velocity and your third parameter is the velocity units. The velocity unit will default to revolutions per minute. So there's that. You can also do percent, which will just give you a percentage of the total power output from that motor. So red motors can spin at a maximum of 100 revolutions per minute. Green motors can spin at a maximum of 200 revolutions per minute. And blue motors can spin at a maximum of 600 revolutions per minute. Do not try and tell it to spin faster than it can go. It will not give you any benefit whatsoever. So I would always recommend just telling it how fast to go and in what units every time you call the .spin command. But you can use that for your basic functions. But obviously you're going to need some logic with that to make it spin only when you want it to, which we'll get into shortly. Another key function is motor.stop. So motor.stop has no required parameters, but you can do break type as a parameter. So the valid break types are coast, which is the default, where it just tells the motor to stop adding power and let it just spin freely. Hold, which will hold the motor in place and prevent it from spinning. And the final one is brake. And what brake does is it will help slow the motor down to a stop. So what motor.stop does is it will stop the motor using whatever you pass or the default stopping mode. And you can actually change your default stopping mode using motor1.setStopping. And once again, you just pass some brake type like hold, brake, or coast. But once again, I would recommend just telling it every time. So say we want it to brake here. So there are really 3 kinds of motor control that are typically used. The first one is you push a button, it starts the motor spinning, and when you push that same button again, it will stop that motor spinning. Okay. A second type is where you push a button to start it and have a second button stop it. And then the third type is it spins only while you are holding down a certain button. So, but to show you that these are indeed valid functions, you can build it, and build works fine. So we are going to delete these two lines. So the first one we're going to talk about is a one button toggle where you push a button to start it, push the same button to stop it. So the first thing you want to do is you want to set up what's known as a callback. So the way you do that is you do controller, whatever your controller's name is, dot button, whatever button you want. There are any valid buttons. It is typically stuff like button 1, button 2, button Y, stuff like that. Button up, down, left, right, X, Y, L1, L2, stuff like that. So we're going to use Y, and then it's the dot pressed function. This is very important, not the dot pressing function that matters. That's very important because the dot pressing function does something different, and I will get into that one in a bit. But you do dot press, and then the one parameter this takes is a callback function. So we're going to call this motor toggle. Okay. So now what we need to do is we need to declare a new function of type void, and it needs to be the same name as your callback, which will be motor toggle, and it can take no parameters. So what we do in a situation like this, where we need one button to turn it on and then turn it off, is we'll create a Boolean variable, call it something like isMotorOn, and you just typically want to initialize that to false. So what we do is we'll say isMotorOn equals not isMotorOn. So what this does is it just sets this to whatever it is not. So if it is false, it will change it to true, because what this not operator does is it just reverses the logic. So in this case, it is currently false. It'll say isMotorOn equals false times a negative, which will be true in this case, and it'll turn it on. And then what we want is if isMotorOn, which is just saying if this is true, then we are going to do something. And if it's true, we want to do motor1.spin, whatever we want, call it forward 100%. And then else if, you can also just use a regular else. I use else if because I do not trust Vex, and if stuff breaks, I just don't like stuff breaking. No one does. I do else if isMotorOn because if this one happens, this one can't happen, as if it's true, it cannot be false. And then I just go like motor1 dot stop, call it coast. And so what this will do is every time you push this button, which is button Y, it will run this function. And so what this function will do at the start, it will reverse the state of this. So maybe if it's false, it'll turn it to true. And then it will see that it is true and start the motor spinning. The way the spin function works is you tell it to spin, and until you tell it to do something else, it is going to do that. So when I say spin forward 100%, until I do something else that tells motor 1 to spin a different amount, it won't change anything. It'll keep doing that. And then once it stops, it will stay stopped until something else tells it to go. And as you can see, I'm going to just show you that this does indeed build. It works fine. And that should work when you upload it to your controller. So the next thing we're going to talk about is a 2-button control toggle. So what we need is we're actually going to need 2 callbacks. We'll use button up. Hold on, I'm just going to make sure that it is not full capital button up. It is not. It is button up dot pressed, and then we'll call it motor on or something, and then we'll want to do the same thing, but we'll use button down and call it motor off. So now we need to create the motor on and the motor off functions. So for motor on, it's simply going to be just void motor on, once again, no parameters. And then all we're going to do here is we're just going to tell the motor to go. So it'll be motor1.spin forward 100%. And this will tell it to start spinning, and it will do nothing else until that. We don't need any fancy logic to get this to work. And then we'll just declare motor off as well. It's going to be the same thing, but instead of spin, we use .stop. Yep, and that will do that thing, and that will, when you push the button up, it'll call this function, which will just tell it to spin, and when you push the down button, it will call this function, which will just tell it to stop. Once again, this will build, work fine, or it will not. Oh, I forgot to do motor1.coast. Once we save this, build it again. Scroll down to show you that it indeed works. We'll show you this whole thing. That all works now. That's why it is very case sensitive, and I always recommend checking as you go. Visual Studio Code is pretty good about error messages, but just in case. And one last thing, make sure you declare all your callbacks before the while loop, otherwise you will just waste a ton of memory by setting up a callback every time you iterate through this loop, which is not necessary and kills the memory of your brain and will slow down your program. So the final one, not the final one, sorry, we have to talk about access values for your drivetrain, or maybe a speed toggle or a speed control. The last one I'm going to, or the second to last one I'm going to talk about is going to be a while holding one. So for this one, we need, if the button is currently being pressed, we need it to spin. Otherwise, we need it to stop. So it's going to be if controller1 dot, we pick our button. No, we do not do that. It is hold on, that's not it. Button. Hold on, I am just checking to make sure. I want to make sure I don't give you false information on accident. So what I'm doing, so what we're going to do, button a dot pressing. I can't remember if it's button a dot pressing or pressing button a, so I'm going to just check it. But basically, it's going to be, if it's this, we motor1 dot spin forward 100%. So I'm just going to test this build to make sure it works. And if it doesn't, it's the other one. Okay, it is that button dot pressing. And then what we need here is an else statement, and just go motor1 dot stop, whatever thing we want. Say we want it break because we really want it to stop moving then at that moment. So this is relatively simple, but you need to make sure that's within the while loop. Otherwise, it won't constantly check. We want it in the while loop, so it is constantly checking this to update it. Another thing we can do with this is say we want another button to reverse it. So we can do controller1 dot button, call it B, and we do else if, because we don't want it to do both if you're pressing both, because then it'll only do the second one in the order. We want else if, because the way else if works, if this if statement gets called, it won't even bother going to this else if or the else. But in the else if, it will be motor1 dot spin, and then say we want it in the opposite direction, reverse, call it 100%. Obviously, you want to control speed more than this, but once again, this is just an example. And then we will go here and show you that all builds just fine. So the final thing I'm going to talk about is going to be drivetrain controls, or like a speed toggle, which is just going to be controlling a motor based on a joystick value. So say we'll talk about say your x-axis, or well, axes are 1, 2, 3, and 4, but so axis 1 is left and right on the right joystick, axis 2 is up and down on the right joystick, axis 3 is up and down on the left joystick, and axis 4 is left and right on the left joystick. So there's two ways to do this. You can set the velocity before, or just put the logic within the motor.spin statement. So we can go, we'll call it motor2 this time, .spin, pick your direction. And then when we're controlling this velocity, axis values for the joysticks are from -100 to 100. If it goes negative, it will spin in the opposite direction. It'll spin reversed. So that is something to note. But there's that. So what this is, it's controller, and then it's just whatever axis you want. We'll call it axis 3. That's typically the one I use for drive. And it's dot position. And that will tell you that value, -100 to 100, on where it is. And when you're doing this, you always want to use %. Otherwise, you have to convert this value from -100 to 100 and scale it for the RPM of your motor. Otherwise, you won't be able to go faster than 100 RPM, and there are very much times when you want to. And the other thing to note about this is we don't need anything telling it to stop, because it will, if you tell it to spin at a speed of 0, it will stop. So when you're not touching the axis 3, this will not move at all, as the axis 3 position value is 0. Some other useful motor functions that you might want are possibly motor .set reversed. So what this does is it takes a Boolean value, whether it's just true or false, and if you are going to have so this is just like in your robot config file where we set the reversed state. You can just set it again with a function. So you're just changing that. I already talked about set stopping. I'm not going to get into the position functions. I will talk about that in a video talking about autonomous and all of the functions that get a value from the motor. But that's a good one to know. And another good one to know is motor2.spin to position. So what spin to position does is, so you just have some position. I would always recommend doing this in degrees. So call it 120. Just you want to go to degrees, which is the default. And then this also takes 3 other parameters, but the next one is velocity, so we can call it 100%. So we want it to go there with 100% speed. And the last parameter is weight. So what this does is whether or not you have to wait for this to finish spinning to its position before it moves on to the rest. So if weight is true, it won't do anything until this finish is executing, which means the motor got to that position. And the other thing is, if it is false, it will just immediately move to the next thing, and that will do itself in the background. And then I guess another one is, or two more are motor dot reset position, which what reset position does is it will just set the current motor position to 0, which default is going to be in degrees, but it will do that regardless. So say you want to move it 120 degrees forward of where it is, it will default to go forward, unless you specify negative, in which case it will go to the reverse of that. But a reset position will just set the position to 0, and then you can do set position as well. And what set position does is you just tell it, like, say you want to tell the motor to think it is currently at the 70 degree position, and it will think that spot is 70 degrees until you either reset the position or set a position somewhere else. So that is motor controls and just some helpful motor functions to know. And as a final wrap up, I will show you that this does not build. Hold on. So what this is basically, so I guess this is a good time we can talk about debugging issues you may run into, because you will run into issues. So what this is, spin to position, it is complaining about velocity units. What? Hold on. Double the rotation units, wait for completion. So what this error message is saying is that it is using an alternate set of, or thinks I'm using an alternate set of parameters, but I am not. So what it seems to be saying is that it doesn't want speed, which means you just set the speed elsewhere beforehand. And I believe this should theoretically build, and it does. So what you just want to do is, before this, you want to do motor dot set velocity and just tell it how fast you want it to go before you do that operation. So sorry about that. I did not know they had changed that function. But this is your weight parameter still. This is your rotation units, and this is your rotation. But that is all for motor and motor controls, and that should get you started on programming all of your user control functions that involve motors.